In this video, we'll talk about the possible number of solutions for systems of linear equations and how we can determine, based on equation structure, how many solutions that a system will have. So we're not actually figuring out what the point of intersection is or what the solution would be for a system of equations. We're just looking at what possibility we are in, given a system of equations. So if we're talking about a system of linear equations, so basically we're looking at two or more lines. In particular, if we're looking at the two-line case. And remember that a line has to be straight and carries on in either direction. So there are three possibilities that exist. The first is that the lines do intersect. And they would intersect at one point, meaning that there would be one solution. And if we look at kind of how this is happening, well, these lines have different slopes. And that would guarantee me that there is one solution. Okay. Another possibility is that what if my lines don't intersect? What if they are parallel? Well, if they're parallel, well, there's no point of intersection, therefore there would be no solution. So if we're looking at this, they would have same slope, but a different y-intercept. And that would kind of make sense, because if two lines have same slope, then we'd be guaranteed that they're parallel. And if they have different y-intercepts, well, then they will never intersect. And there is a third possibility, and it's a little bit weird, kind of given the context here, but it would be hypothetically, what if I graph these things and they are indeed the exact same line? And we'll talk about kind of an example of what this would look like, but this is definitely a possibility. And in this case, we would say there is an infinite number of solutions, because it doesn't matter which point I pick on the line. If it's on one line, well, it's on the other line too, because they are the same line. So this would be an infinite number of solutions. And that happens when I have the same slope and same y-intercept. So if we're looking at two lines, these are our three possibilities. Either we have one solution, and that'll result if we have different slopes. Y-intercept is not a factor really there. Or I could have parallel lines, which would be the result of, or would have no solution, and that happens when I have same slope with a different y-intercept, or they could in fact be the exact same line. And in that case, I would have an infinite number of solutions, in which case I'd have same slope and same y-intercept. So let's kind of put this into practice here. We're not solving this system, but let's say I wanted to just kind of give myself an idea of, okay, how many solutions could I have? Which possibility am I in? Am I at the point where my lines intersect? Do they not intersect, or are they indeed the same line? If I'm looking at this case, I can look here, and based on my equation structure, which in this case they're both in slope-intercept form, so y equals mx plus b, where m is the slope and b is the y-intercept. Okay, now if we're looking at this, I have different slopes. Now because these slopes are different, meaning they're not equal, I can say that this is only going to have one solution. Meaning that when I do solve this system, there will only be one point, one particular coordinate where these two lines have the same value. They will only have one that they share. So let's look at another example. Let's say I want to determine just the number of solutions for this case. Again, I'm going to look at the slope. In this case, I have the same slope. Now I have to take it a step further. I have to look at my y-intercept. So I have the same slope, and I have different y-intercepts. This would tell me these lines are parallel. meaning that they will never intersect, meaning that they don't have any common points or common coordinates. So that would mean that there is no solution. And now if we look at a third example, this one's a little bit tricky, I guess, sometimes a little tough to see. If I look at this second equation here, I could distribute this 2 in, and then this would be equivalent to 2x plus 4. And usually you'll have to do a little algebraic manipulation, and then once you do, you'll realize that, hey, those are exactly the same. They both have same slope, and they have the exact same y-intercept, which would mean that they are the same line, which means that we have an infinite number of solutions. So there's an example of each case, and there are only 3 possibilities. And again, we're not solving the systems here. We'll talk about that in a later video. This is just kind of an idea to help build the understanding, and also when you are solving, you can use some of your knowledge so that if you're working it through and you realize, okay, this should have one solution, and you actually get infinitely many, something weird happens somewhere. Either you made a mistake with your algebra, or there was a mistake in the interpretation with what number of solutions you have. So this can not only be a useful tool for building the understanding of systems of equations, which is what we usually do, but it can also be a way of checking to make sure that when you do solve systems of equations, the solutions make sense, they check out.